Hello, ladies and gentlemen. Here we are following up with one of our more grueling lessons, the rational root theorem, with something known as the intermediate value theorem. Now, this is going to kind of piggyback with some of the things that we did with the rational root theorem, but not be quite as brutal. Now, there are some things related to it. In fact, one of the things intermediate here is really talking about something specific, but there's three very distinct topics that we're going to be discussing in this lesson, where the intermediate value theorem is really only one of the three. So what you're seeing here on the screen is the definition of what the intermediate value theorem is. Now, I do want to specify, yeah, they do really need to kind of mention some of you at some point have asked, well, why do they have to say it's a real coefficient? Well, it is very possible. You've seen in other lessons that imaginary numbers are a very real thing in math. So yes, they do have to specify if something is a real value or not. Now here, what it's telling you, A and B are going to represent some number that we substitute into the function, and they have to be successive numbers, meaning if A is 1, B has to be 0 or 2. Okay, they have to kind of be in order. If A is 3, B would be 4. If A is -8, B would be like -7 or something like that. Okay, and here, where it's telling you opposite signs, basically that's what you're looking at. If you substitute those values in, whatever A and B happen to be, the outputs should be opposite signs, meaning one should be positive, one should be negative. And if that happens, what it's telling you is that it's crossing the y-axis at 0, so it's touching the x-axis, meaning it produces a 0. Now this will make it a little bit, this is a much more language-friendly version of the explanation. So make sure you get this copied down into your notes. Basically, if you have, like, say, f of 2, let's say whatever function f is, I'm just making this up. If we have a function called f and we substitute the number 2 into it, if it gives me a positive number, okay, whatever that number is, well, the next number coming after that would say, let's be 3. That would be the range that we're looking at. So if that number is if that output gives me a negative number, basically what it's telling you is between 2 and 3, whatever function that we have is crossing the x-axis at that point, where it's touching the x-axis at that point. So even though it may not be a whole number between 2 and 3, there is a 0 between 2 and 3. And that's what the intermediate value theorem is saying. So it's not going to be a whole number, but it is a number between these values that will be 0 or a solution. So let's take a look and see what we have here. Now, this is going to make sure when you're working with these, you need to make sure that you're paying attention to how you plug the numbers into the calculator. Again, I mentioned it several times. If you're substituting negative numbers into a function, make sure you put that negative number in parentheses in your calculator before you raise it to a power. So here, if we say f of -3, when we write it out, we're basically substituting that number in. So we're going to say -3 to the 4th power, etc., minus 2 times -3